In this session, I'm going to talk about using tables in R, wherein we'll have a quick introduction of what is the main purpose of tables, right? In which cases tables are more preferable compared to, let's say, the graphical world. So that's the introductory part that we are going to look at. Then we are going to talk about the table function, one of the most important functions with respect to the tables, especially when I am doing preparing a table of counts of the data. And when I am working with summaries, right, if I have to create some kind of mean, some kind of standard deviation, some kind of summaries, then I can use a function called tapply, which is more or less similar to the usage of aggregate function which you have looked at earlier. So we would be talking of how we can use tapply as a function. Then once I get a table, how do I really expand it into a data frame? Right? Once I have a summarized information in the form of a table, how can I expand it into the raw data kind of a format? So that's one more thing that we are going to look at here. Then table wise, okay, we are making a table of counts etc. of the raw data. Again, if I have to really get into creating table of proportion, right? Proportions, row wise proportions, percentages row wise, percentages column wise. So if I have to create these kind of proportions, what is that I can do? And towards the end, we are going to look at a few other important functions which are very essential from the perspective of tables. So let's get started. So if you want to convey the details, right, if you want to get the big picture of any kind of a data, we can use a graphical presentation. Whereas if I want more and more details into the data, compared to a graphical presentation, a table is more and more important. So more effects wise, or if I'm looking at the broad picture wise, then compared to the tables, graphical representation is much better. But if my focus is giving in more and more details to the data, then tabular representation is much better. And when you are trying to summarize your data, especially when your explanatory variables are categorical. So when you find that majority of the variables are categorical variables, let's say in our customer data that we have been using, right, looking at whether they own a home or not, or looking at the segments of different kinds of customers. So they are all categorical in nature. So if my explanatory variables are more categorical, then having tables is much more appropriate compared to using a graphical format. Of course, graphs also we have seen, if there are categorical variables, we can very well use box plots. But if two variables are categorical also, still I can use a table, but there may not be much of a use by using any of those bar charts and all, because one of them should be a scale variable there. So if the variables are more and more continuous, I can think of a graphical way of representation, but summarization through tables is much more effective if my variables are more and more categorical in nature. So here to start with, I would be talking of two important functions. One being the table, where my intention is to count the different things in a particular table, right? Count a particular variable, different occurrences of the different categories in a particular variable. And when I'm talking of tapply, more similar to aggregate, I'm trying to apply some kind of functions like average, standard deviation, median, etc. Any other functions across the various factor levels, more and more similar to the usage of your aggregate function itself. So let's get started with the table of counts. right? It's one of the most useful and it's one of the most simplest of all the vector functions. So what it does is simply counts the individual occurrences. So it can work for the character variables. Of course, for character variables, there's a lot of meaning to it, but you can use them for numbers as well, right? So each number, how many times it has occurred is what it is going to produce. So let me take this particular data so that we can have a discussion on this. So let me get my customer data. Now in this customer data, now I can try to find out how many, right? If you look at the head of the customer data, just for a quick refresher, this is what it is. So I want to find out the table of customer dollar segment. How many are there from each of the segments? So I get a quick table saying moving up segment there are 70 people, suburb mix segment there are 100 people, traveler segment there is this, and urban hip there are 50. The same logic probably I can use it for gender, wherein I am getting there are 157 females in the data and 143 males. So that's how I can use my table function. I can do it even on numbers, but there is no meaning to it. But of course, yeah, let's say I'm generating some kind of observations from a Poisson distribution, right? Let's say POI is the name of the variable that I'm creating. So I'm randomly generating 1000 observations from a Poisson distribution with a mean of 1. Right, so that is what is the POI. Now I want to find out the table, each one how many times it has occurred. So I'll say table of POI. Now I could see that 0 has occurred 402 times, 1 has occurred 354 times, 2 has occurred 183 times, 3 has occurred 51 times, 4 has occurred 8 times, and 5 has occurred 2 times. So I can get it for the numbers as well, especially if the number of categories are, number of variables, the number of observations are very few in number. But if I do it on, let's say, income, there is really no meaning because almost all incomes are there altogether. So there is no meaning in terms of creating such kind of a table for the income related variable. And I can use them for multiple variables as well. So here if I say table wherein I'll give gender, right, gender is my one variable, comma segment. So I'll give two variables. Now that way if you see it comes out as a two-dimensional table, female and male are coming here, 4 segments are coming here, and the typical counting across each of these 4 segments has come up. So this is the quick way of creating a two-dimensional table, right? So the one that is given in the first appears in the rows, the one that came the second appears in the column. So it produces a two-dimensional table. So X is whatever you have given as a part of X, it comes as rows, whatever you have given as Y, it comes as column. So that is one way you can use the table function to generate a quick summary of your data. Then the next important function that comes in handy here is the tapply function, where you are creating summary tables, more or less similar to your pivot table function in Excel. So whatever is the function that you want to create, whether it is mean or median or, right, you can talk about standard deviation, minimum, maximum, whatever is the name of the function, across the specified factor levels, and the output is a table. Now this is where you are using the tapply function, wherein you are giving the response variable, what is that you want to summarize, the factor variable across what you want to summarize, and what is the function that you want to apply. Now this is what will really help us in creating the tapply. So let me say I'm creating a tapply function, right? So I'm looking at the average income. So I'll say customer dollar income, that's my response variable. Now if I say my explanatory variable, which is a factor, I'll take it as segment, and the function, let's say I'm taking it as mean. Now this is how it is applied. Moving up segment, this is the average. Suburb mix, this is the average income. Travelers, this is the average. And if you look at the class of this would be a table kind of a class. So that is where the T apply is coming in favor of us. Now here also I can very well create the two-dimensional stuff, wherein these variables, so let's say if I want to give segment along with gender, create it as a list, right? So put the gender here as one of the variables, then take the second variable segment, both of them let them be enclosed in the list, and that's it. Now you see female and male. Moving up segment, this is the average income, whereas for the females, this is the average income. In the suburb mix category, females have, this is the average income for the females, this is the average income for the male. Traveler segment also, females average income is looking slightly higher than the male, whereas in case of the urban hip, it is slightly looking the other way. So this kind of a quick tabulation also can be performed. Two-dimensional tables. So instead of single explanatory variable, I have created two explanatory variables, but when I am bringing two explanatory variables or more than two, then I should look at using it as a list rather than a simple explanatory variable. Just like the way we have given here, I have to mention it as a list. So you have to specify which of these two variables has to be used in the rows. The first one will be used in the rows. The second one would be used as a part of the column. Now I can very well write my custom functions also, right? So instead of computing the mean, I can say function of x, wherein I can put as d of x divided by mean of x. I'm looking at the coefficient of variance. So here also I could see the coefficient of variance for females is much higher in the moving up category, whereas it is much higher for males in the suburb category, even more higher in the travelers category for the males. So I could see this is how the coefficient of variance is differing across the groups. So even I can write my custom functions also accordingly. Now if I am bringing in the third dimension, right, instead of just two dimensions, let's say I'm bringing in the third dimension also, customer dollar own home. If I bring in the third dimension also, then you see it is, the table is becoming like this. On the third dimension, whatever are the variable, whatever are the categories that are there in the own home segment, in the own home variable, there are two categories: own home yes, own home no. So the tables would be created separately. For own home no, this is the table between this is the average salaries of the females in the moving up segment. This is the average salaries of the males in the moving up segment within those who don't own a home. For those who own a home, these are the average incomes of the males and females in the moving up segment. So you'll get breakups between the owners and the non-owners, and that too between males and females. So you can add any number of dimensions, but this is a stack of the two-dimensional table. Especially when you are generating three-dimensional table, what you are going to get is the stack of the two-dimensional table. And number of stack tables, here I got two tables. The reason being, the third category, the third factor is actually having only two different categories. So that's the reason I'm getting two different stacked tables. So depending on the number of levels that are present as a part of the third factor, so those many stacked tables are typically going to come up. So in this case, I got these many stacked tables. Now the same thing, whatever I have got, if on the top of it, if I'm putting F table is nothing but flat table. I'm making it flat. If I'm able to put it as flat table on the top of whatever the T apply that I've created, it comes slightly better. Okay, female. Now the third dimension comes in here. Own no, own yes. Now here it comes out like this. Females in the moving up segment, in the suburb mix segment, in the traveler segment and the urban hip segment. Similarly, male in these four segments. So this is a kind of a flat table. Sometimes we may prefer having a table like this. So either of the ways, so you can get the representation in this manner as well if you are using F table as a representation. So if you are looking at the ordering that is happening for the rows, columns here, right? Female is taken as the first in the preference and male is taken as the second. Even here you could see moving up is first, suburb is second, travelers is third, urban hip is fourth. Here also no is first, S is second. So it looks like everything is in the alphabetical sequence of the factor level. Now if you really want to change it, every time you have to give the factor of, give a factor variable, and based on that factor variable set your levels in the order. So just let me try it for the males, right? So you could understand if I'm setting it just for the males, the whole thing, right? If I say gender, I want the males first and then the females. So what is that I will do is I'll set the factor of customer gender, wherein I will set the levels. The first level I would like to set is the male, and the second level I would set is the female. I don't want it in the original order, I want it in a sorted order, in my own order. Now this is where I'll use the factor, wherein I am taking the gender and the levels I am assigning my own. Now this is where you could see initially you are first getting the male and then the female. Otherwise the default order is the ascending order. So wherever you want the order to be changed, you want to get the order of your requirement. Then what is typically desired is whichever is your factor variable. So create a factor on the top of it, and then comma the levels, you set the levels, the order in which you want them. That is how you can very well create the table of your choice rather than going ahead with the default table that typically comes up. Then in the T apply, sometimes we can even go with some kind of extra arguments as well. I can very well set the trim. Trim means it is typically doing the trimmed mean, wherein I can specify a fraction, right? 0 to 50%. I can specify some kind of a fraction of the observation. So if I am talking of these are the actual observations, when I am saying trim of 0.05, so 5% of the observations will be trimmed from this side, 5% of the observations will be trimmed from this side, and the mean would be computed only for these kind of observations. Now that is what we are typically calling as trim. So if I want to quickly look at the same thing within the mean, when I am computing the mean itself, I can very well set trim equal to 0.05. So almost 0.5% of the observations or 5% of the observations will be trimmed from both sides. You could see here in the suburb mix, you see a slight difference with respect to the means for both the groups because some set of values are trimmed from both the sides. Right? You could see small changes in the values because some observations have been trimmed from both the sides. Now, that is one kind of an argument that you can bring in, and you can also set another important argument na.rm equal to true. Especially if your data is having so many NAs in it, if you want to remove those NAs, you can very well set na.rm equal to t or equal to true, where all the missing values will be removed before computing the mean. And if you want to convert the now we have got it as a table, right? Now if I want to convert this table into a data frame, whatever the table I have got, this is the table that I have got, the T apply, right? This is the table that I am having. Now I want to convert this into a data frame. Now this is where I can say as dot data dot frame dot table, as dot data dot frame dot table, wherein I am giving the tapply function as the input. Now I could see that this whole thing, whatever was my tapply, it got created into a table. Very interesting one. Okay, the variable 1 is showing the gender, variable 2 is showing the moving up and these kind of categories. So this whole thing got generated in the form of table. Variable 3 is showing as own no and own yes, and variable 4 is showing as frequency. So the only thing now is I can very well edit the headings and change them through the names function, right? Probably I can set it as names of, I did not give anything to this. So what I can do is I'll put tab 1, right? I'll call this entire thing as tab 1. Now this I can say names of tab 1, wherein I'll set it as, first one I'll set it as gender, the second one I'll set it as segment, the third one I'll set it as own, and the fourth one I'll set it as mean income. So that way my table is much better now. The tab 1, if I look at gender, segment, own or not, mean income. So as dot table, as dot data frame dot table is typically a very interesting one, especially if you have a multi-dimensional table. You can very well convert it into a data frame by doing this kind of a exercise. That becomes more and more easier for us to really evaluate each and every segment of this table once it becomes a data frame. Now, the next part is there could be some scenarios where I may have to expand a table into a data frame, right? So I may have some kind of a quick output wherein I may have to look at, so let me do some kind of counting operation. So as a part of my summary, let me create one. So let's say I have table of, let me take it as let me take 3 groups: customer, dollar segment, customer, dollar gender. I'll take it as customer, dollar own home. So I'm taking the table of these 3. I'm getting it as 2 sets, 2 stacks of 2 different tables, right? So now I'll convert this whole thing into a data frame. So you could very well see now tab 2, I'll call it as dot data frame dot table, wherein I'll give this table as the input. So if I look at tab 2, I've got something like this, right? So these are the different counts. Now from here I'm talking about, I want to create, now let's say this is the summary table that is given to me where the different counts are being given. I want to create a data frame with as many repeated rows as specified by the count. So I want to create this 34 times. Moving up female, oh no. Moving up female, oh no. I want to get it created 34 times so that I can recreate the data from the data frame. Now this is where I'll do an lapply for each. I'm creating it as a list apply, wherein I'm taking the table name, right? I'm taking the table name, so it's better that I have it as a table. So I can give the name of this particular data frame, which is tab 2. I have to give it as I have to give a function to it, wherein I am repeating this x, which is whatever is the whole variable, because I am doing it as an lapply, and table name $count. So those many times, here frequency is the variable that I am going with. So I'll do a simple lapply if you are getting it for every column. So I'm taking the name of the table tab 2, the function that I'm typically applying, function of x, wherein I'm saying I want to repeat x how many times, tab $2 fric times. So for every column, because I am doing it as a lapply, for every column, what it will do, it will apply this function that many frequency times. So immediately once you look at it, you are getting each column 300 times, right? var1 you are getting 300 times because it is repeated, x is repeated, and this function I am applying it to tab 2. So every observation is repeated those many frequency times. So moving up is first repeated 34 times, then suburb mix is repeated 23 times, and so on. Every observation is repeated and everything is in the form of a list. So repeat each variable in the table such that each row is repeated the number of times specified by the count related vector. Now the whole object you got it as a list. Now you can very well convert it into a data frame using as.data.frame. This whole thing, right, you can very well convert it into a data frame. So let me call this as df1, wherein I'm saying as.data.frame this whole lapply. Now if you look at your df1, it is coming out purely, each thing is coming those many number of times, and if required you can very well omit the last one. You can very well take out your last column, the redundant vector of counts you can remove, and you can generate the observations 300 times. So you can very well convert the data frame into a table, right? And again you can do as.data.frame. So the tables converted into data frames into a table. This is one important application that you really need to be comfortable with. Then the next important operation with respect to tables is calculating the table of proportion. So here we will be using a word called margins of the table. Margin equal to 1 means typically the rows of a table. Margin equal to 2 means we are referring to columns. So margins are typically used for calculating proportions, right? I'll be talking about the overall row wise or column wise. Proportions will be different when they are expressed as a fraction of row totals. In some cases I may want to do it as a proportion of row totals. In some cases I want to do it as a proportion of column totals. Right? If you really look at the customer related stuff that we have created in the beginning, I may be interested, let's say we are talking about this kind of, right, we are talking about a tapply function like this, or tapply function where we have used the mean, right? Let's say this is the one that we have used. So this one, or even the counts, we have used, let's say, table customer dollar segment, right? I have to use capital S, comma, customer dollar gender. So let's say I've created a table like this. Now I want to take this as a proportion table. So this is where I'll talk about prop.table. Now for that I have to give the input as the table itself, right? I'll give the input as the table, and if I set 1, then it would be expressed in the form of proportion of rows 49 and 21. So 49 divided by 70, which is 70%, 21 divided by 70, which is 30%. Similarly, 48 by 100, 52 by 100, 40 by 80, 40 by 80, 20 by 50, 30 by 50. So that is how the when I set margin equal to 1. But when I set margin equal to 2, it would be done as a part of the column total. 49 divided by 49 plus 48 plus 40 plus 20. So that is where 31.2%, 30.5%, these are the percentages that are coming up. So these are the column totals. If I want to do the proportions based on the column totals, I can use prop.table with margin 2. And if I really don't want any one of them, I can simply say prop.table, wherein out of the grand total the proportions are typically computed. So all these put together will be equal to 100% here. Out of the total the proportions are typically being expressed. So proportions are expressed as a fraction of the grand total if I don't specify the margins. But we have to really think carefully whether it would make any kind of a sense to express our counts in terms of proportions. So if at all we have to express them as proportions, would it be good enough to express them as proportions of row total, or would it be good enough to express them as proportions of column total, or would it make sense to express them as a part of the grand total? So this is also one more area that we need to be comfortable with. Then moving towards other important functions that we can work with tables. One is scaling, right? Where I am typically trying to do a scaling. So scale the values within a column so that they have a mean of 0. So I am trying to find out the scale where the mean of the values is going to come to 0. So if I am going to give the counts as the typical inputs, and the scale is going to do, probably if you see here, if I am saying the scale of, let's say, the whole table I am giving as an input. Now it is what is converted in this way. Or if I am giving the scale of the typical data frame itself, now if I am giving this as a scale, the way it would be computed is the everything is set in such a way that the mean is 0. You could try to find out the mean of this whole thing, 0.72, 0.65, 0.05, minus 1.43, overall working out to be a mean of 0. Minus 1.1, minus 0.4, minus 1.5, plus 1.5, again working out to be a mean of 0. So scale whatever you are giving, for each column it would be said that the mean is 0, right? And the values in the tables are coming out as the count minus the column means. So whatever is the count value that you are getting minus the column mean altogether. So that is how and it is scaled based on the standard deviation of the star. Now if you are trying to look at the standard deviation of each of these, So it is coming out to be overall the standard deviation is coming out to be this much. But if you look at the standard deviation of all the rows first column, the standard deviation is 1. You could also take the standard deviation of all the rows second column. Even that would be 1. So the scaling would be done in such a way that for each of the columns, the mean would be 0, the standard deviation could be 1. So that is the way the scale function typically works. So if I want to scale any of the columns related stuff, the way we are doing the scaling is each observation is subtracted from the mean and divided by its standard deviation. That is one more thing we call it as we compute the Z scores of that particular columns. Then the other important function that can come in handy with respect to the tables is the expand.grid. So it's a useful function for generating the tables from factorial combinations of the factor levels. Let's say I have different kinds of factor levels, right? Fact variable 1, variable 2, variable 3. I know that the variable 1, so let's look at it like this. So let's say if I am talking about expand.grid, I have the, let's say 3 variables, right? I'll call variable 1, which is a sequence from, right, I'll say variable 1 equal to 1 to 5. I have 5 different values of variable 1. I'll say variable 2 is having 6 to 8 and variable 3 is having some other stuff, let's say a comma b. So I'll give it as a comma b. Now I want to generate the whole grid with this. If you look at this values here, I have to mention variable 1 equal to 1 to 5, variable 2 equal to this much, 6 to 8. Where did I put this comma? Oh, this one, it has to be a common bracket, not this brace. So if you see here, the first one is having 5 values, the second one is having 3, the third one is having 2. So the expansion is nothing but 5 into 3 into 2. So 30 rows of data should come. So you could see 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 expanded these many times. 6, 7, 8, 6, 7, 8, 6, 7, 8, A, B, 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 B. So the whole thing is expanded in one single shot. So that is what is being performed by expand.grid kind of a function. Then in some cases we have, instead of using the table as a function, we talk about using tabulate as a function. Table we are very clear by now, but tabulate typically counts all the integers, turning the real numbers into the nearest integer if necessary, and it keeps putting the values zeros wherever things are not present. So in this case we don't have direct zeros not present kind of a scenario. So it would be better to take a separate example for this, right? So let's talk about negative binomial distribution, right? So let me take a table Rn binom, a negative binomial distribution where I am generating 100 values with a mean of 1 and a standard deviation of, let's say, 0.2. So if you see here, if you are doing a simple table, we see that, okay, 0 is repeated 25 times, 1 is repeated 17 times, like this, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 12 there is a 15, so 13 and 14 are not there. Then again 16, 17, 18 did not get repeated, 19 came 2 times, 20 came 1 time. Now this is the one thing which a table gives. But if the same thing, right, probably we should take the same example so that the duplication does not come out. So let me set a seed so that our output will remain the same in both the cases. So I'll set a seed as 100. Now then I will take the table function. So this is what is being given by the table function 0, 1, 2, 3, 4, 5, 6, 7. 10 came once, 8 and 9 are not there, 11 is not there, 13 came once, 14 and 15 are not there, and only 33 came after that. Now but the same thing if I set seed again 100, but if I use tabulate instead of table, right, instead of table, if I am using the tabulate function, I will get the same thing 17, 20, 11, but it does not work for 0. So for that what people do is they say plus 1, right, instead of just getting this values. So again let me do a set seed. So because this tabulate works only from 1 onwards, what people do is whatever is the negative binomial, you add 1 to it. So now you could see 19, 17, 20, 11, 8, 4, 8, 8. Up to here it is fine, same as table. But because 9 is not there, here it will show 0. Again 10 is not there, 10 is there once, so you will get it once. So 8 and 9 are not there, so they are showing 0, 0 type. Now this is what is an advantage you will get with the tablet, especially when you want to make the size of the output similar in all the cases. You can very well use the tabulate function, but we have to be very careful here. It does not work with negative numbers and zeros, as we have seen now. It did not work with 0. It did not display how many zeros have come. So it's always better that I add 1 or something to it after I have generated the values, so that I don't get all these kinds of issues when I am displaying the overall tables. So these are some of the important things that you have to keep in mind when you are working with tables. I hope you have got a decent amount of understanding on the different kinds of functions that you can very well use when you are working with tables. If you have any further queries regarding the same, you can very well get back to me by giving me a call on the number that I have given below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.